So ngayon po is gagawin po natin yung first come first serve scheduling algorithm. And may bigay sa ating nagibit. Yung nagibit po natin is process, arrival time, and burst time. Yes, yung unang gagawin po natin is hanapin po natin yung pinakamababa doon sa arrival time. At tulad po ni P2. P2 is mapupunta sa RM. Tapos ipaprocess po niya ni CPU. At ngayon po is nandito po si P2 and dito po is 0. And ang sunod po natin is si pinakasunod niya po is si P1. P1, buburin po natin ito tapos ito. As si P1 naman po yung process. P1. P1. Tapos nandito na po si P1. At yung matatapos naman po ni P2 is burst time niya is 8. At si P1 naman po is tanggalin na po natin si P1. Kasi yung burst time po ni P1 is i-add lang po natin siya doon sa 8. Tapos magiging 11 po siya. Tapos ilalagay na po natin si yung sunod po ni P1 is si P4. Tapos ang sunod na po naman po ni P4 is si P0. And ipaprocess na po naman nga sa sunod is si P4 naman po. Tapos buburin na po natin siya, tapos pupunta po siya dito. P4, tapos yung 11 na po is i-add natin po siya sa burst time niya doon kay P4. And magiging 15 po yung burst time po. And sunod naman po is si P0. Dito mapupunta po siya dito sa CPU, magpaprocess po siya. And P0, i-add po natin yung 15 ngayon sa burst time po ni P0. P0 is 5, 5 plus 15 is 20. And yung natitira naman po is si P3. Magpaprocess na po natin si P3 and P3. At yung burst time ni P3 is 6. Eh, i-add natin po sa 20. 20 plus 6 is equal to 26. And sa completion time naman po tayo, dito po sa City. Yung gagawin po sa City, completion time is, yung saan lang po sila natapos, katulad po ni P0. Natapos po si P0 is sa 20. Lalagay po natin siya sa 20. Tapos natapos po si P1 sa 11. And dito na po siya. 11, P2, 8. P3, 26. And sa P4, 15. Sa turnaround time or TAD is, i-minus natin si City minus 80. Yan po. City minus 80 is equal to 12. And 11 minus 1, and 8 minus 0, 8. 16 minus 15 is equal to 11. And 15 minus 5 is 10. Dito naman po sa waiting time is, T80 minus WBT, burst time po. Tapos, yun na po, makuha na po natin sa waiting time. Ito naman. Turnaround time minus burst time is equal to 7. Turnaround time minus 3 is equal to 7. Turnaround time minus burst time is 0. 11 minus 6 is equal to 5. 10 minus 4 is equal to 6. At, and sunod na po natin is si response time. Dito po is, makuha po natin siya dito kailangan po niya si arrival time on chart at arrival time minus arrival time on table po. Yung arrival time on chart niya is ito. Sorry. Arrival time in table is ito po. Ito po. Ganito po siya yung minus. Ingali po si P0. Kung saan po siya dumating. Ingali po. Dumating po siya is 15. 15 minus 8 is 7. Dumating naman po si P1 is 8. 8 minus 1 is 7. Dumating naman po si P2 is 0. 0 minus 0 is 0. And dumating naman po si P3 is 20. 20 minus 15 is 5. And dumating naman po si P4 is dumating naman po si P4 is 11. 11 minus 5 is 6. Yan po. Nakuha po na natin siya lahat. And then sunod na po natin is yung total naman po ng mga nakuha po natin. And mahanap po natin si total turnaround is dito. I-add lang po natin itong 12, 10, 8, 11, and 10. Yung total po niya is 51. 51. And yung average naman po niya is yung total ng turnaround time. Tapos po, yung ilan po yung process natin is divided by 5 is equal to 10.20. And yung total waiting time naman po natin is i-add lang po natin ito. Tapos yung total waiting time po natin is 25. Tapos yung total waiting time natin is i-divide po ulit natin siya sa 5 is equal to 5. At dito naman po sa throughput is hahanapin po natin yung ilan po yung process po natin. Kasi yung process po natin is 5. Tapos po yung pinakamalaki po natin doon sa completion time po natin is 26. Ito po siya. Completion time po natin is 26. Yung pinakamalaki po. Tapos po yung minus po natin si completion times doon sa arrival time po natin na pinakauna is yung arrival time po natin is 0. Minus 0 is equal to, tapos po is times po pala, times po sa 100 is equal to minus 5 minus 26 is equal to 19.23. 19.23. Kasi times po natin siya sa 100 is equal po si 19.23. Dito naman po sa CPU util is yung total po ng burst time po natin is equal to 26. Tapos po is i-divide po natin siya doon sa pinakauling process po natin doon po sa arrival time is ito po si 26. Right? Times 26. Tapos divide 26 tapos i-times po natin siya doon sa 100 is equal to 100% po. Ganun po yung process yung first come first serve po natin. Ganyan lang po yung pag-compute natin doon sa first come first serve po natin. Ganyan po. Sunod na po natin is si shortest process first algorithm po natin. Is parang parehas lang po niya ito si first come first serve. Is yung giving ulit po natin is si process, arrival time, burst time po. Is yung ganun po ulit yung gagawin natin. Yan, dito po, yung unang anin natin dahil siya yung pinakamababa po. Dito na po siya, i-process po natin siya dun sa CPU is dito. Itong 0 is given na po siya, 0 time na po siya. Dito, yung burst time niya po is 8. Kaya po, yung last process burst time natin is 8. And sunod po natin is si P1, P4, is si P0. Tapos yung unang anin po ni P1 is yung unang process po natin is si P1. P1 po, dahil siya po yung pinakasunod dun sa pinakamababa. P1, tapos i-add po natin yung burst time niya dun sa 8, is magiging 11 po. Tapos sunod naman po is si P4. P4, process po natin siya dito. Yan po, tapos magiging equal po nga is 15. Yan po, 15. Kasi ipaprocess po natin siya dun sa 4. And sunod po natin is si P0. P0. Paprocess na po yan si CPU, si P0. Tapos 15 plus sa P0. Burst time niya. P0. P0, ito po. 15 plus 5 is 20. Sunod po natin is si P3. P3 po, nalagay po sa CPU. Yan po. Tapos po si 20 plus 6. Yan na po. Magiging 26 po siya. And makuha po ulit natin si completion time dun sa end po natin ng pagpaprocess po. Katulad po ni P0 is si 20 po. Yan po. 20. P1 is si 11. P2 is si 12, ay si 8, P3 is si 26, P4 naman po is si 15. And makuha po natin si turnaround time is, ma-minus po natin si completion time at si arrival time. Arrival time is minus mo na natin. Si completion time minus dun sa arrival time is magiging 12 po. And si completion time minus dun sa arrival time is 10. 8 minus 0 is 8. 26 minus 15 is 11. 15 minus 5 is equal to 10. At makuha po natin si waiting times. Pag po, pag minus natin si turnaround time dun sa burst time naman po. Dito po. Burst time. Turnaround time minus burst time. 12 minus 5 is equal to 7. 10 minus 3 equal to 7. 8 minus 8 is equal to 0. 11 minus 6 is equal to 5. 10 minus 4 is equal to 6. Yan po. At si first one time naman po na tayo. Makuha po natin si first one time dito po si, makuha po natin siya dun sa, pag minus po natin si arrival time on chart and arrival time on table. Ito po si arrival time in chart. Ito po si table. Yan po. Arrival time in chart. Ito na po. Nahanapin na po natin si this one time. Unang natin si P0. P0, yung arrival time niya is 15. 15 minus 8 is equal to 7. Arrival time naman ni P1 is 8. 8 minus 1 is 7. Arrival time naman po ni P0, P2 is 0. Yung 0 minus 0 is 0. Arrival time naman po ni P3 is 20. So, minus po natin si 20 dun sa 15. Si 5 na po, yung matira. And sunod po natin si P4. P4, 11 minus 5 is equal to 6. And yung sunod po natin is patulad lang din po sa una. Total turnaround times and average time of turnaround time. So, yung total po ni turnaround time is si 51. At yung average naman po ni turnaround time is, kukunin po naman natin si turnaround time, tapos po, i-divide po natin siya dun so, ilan po yung process natin. Divide po yung process natin is, equal po niya is 10.20. Dito, and sunod po natin is total time, total of waiting time, yun po. Tapos yung average po ni waiting time. Yung total po ni waiting time is 25. Tapos po, yung average po natin, average waiting time po natin is 5. Kasi po, yung 25, yung total po ng waiting time, i-divide po ulit natin kung ilan po yung process po natin is equal to 5. Throughput po natin is, yung ilan po yung muna yung process natin is 5. Tapos yung pinakamalaki naman po natin ng completion time po natin na si 26 po. Yan po siya. Ito po siya yung pinakamalaki natin is 26. At yung minus po natin siya, doon naman po sa pinakamababang arrival time natin na si 0 po. Ito po, si 0. And tatimes po natin siya doon kay 100. And 5 divided by 26 is equal po doon kay is 0.1923. And pag tinames po natin siya sa 100 is magiging 19.23 po siya. And si PO po natin is yung ilan po yung burst time po natin. At yung pinakamataas po natin doon sa arrival time po natin na si 26. Tapos ita-times po ulit natin siya doon sa 100. 26 divided by 26 is equal to 100. Yan po. Yung susunod po natin is si shortest remaining time course. Yung ano po niya is si burst time in selecting process po natin. And yung ano po ni SRTF, di na po katulad nung dati natin gagawin. Yung RTF na yan is preventive time of algorithm. Ito po yung given natin is si process niya. 0 to 4, 80, burst time. Yun po. Yung una po natin gagawin is si, lalagay po natin si 0. Si 0 is si P3. Kaya po ilalagay po natin dito si P3. And sunod po natin is makukusyon po ni P3 is 3. Kaya po magiging 4 po si tapos po, ano na po si P3 at si P0 dito. At babalik ulit po dito si P3. And sunod po naman po ni, sunod po, makukusyon na po ni P3 is 5. Dahil po, 5 po yung dito. Magiging 2 na lang po. Ito, si P3. Yun po. Tapos po, mapupunta na po dito si P3, P0, and P1. At nandito pa rin po si P3. At mag-start na tayo dito kay time 7 na po. Kasi, makukusyon na po dito yung burst time po ni P3. At susunod na po kay P3 is si P0. Dahil yung sunod po ni P0 is yung kasunod po ni P3 is si P0 and P1 po. At yung magpaparas naman po dito is si P0. At yung magiging time niya po is 8. Kasi may darating pong isa pong process na po natin na si P2. At po, mababawasan po si P0 is magiging 3 po siya. At nandito na po si P0, P1, and madadagdag po si P2. At yung ilang mababang burst time po natin ngayon is si P0. Kaya po, mapupunta po dito si P0. At yung sunod po natin is may darating pong process na si P4. Kaya po, ikukusyon po natin lahat ng burst time ni P0 na magiging pong 8 plus 3 is magiging 11. At matitira po ngayon is si P1 at si P2. And gagawin na po natin itong 0 para po hindi tayo magkalito. At yung sunod po natin is yung sino po yung pinakamababang burst time po na sino po yung pinakamababang burst time po. And yung pinakamababa po natin is si P2. Kaya po ilalagay po natin dito is si P2. At kailangan po dito tumigil ni P2 kasi po 12 po yung algorithm. Dahil po si arrival time po ni P4 is 12. Kaya 12 lang po yung ano natin dito. At papasok na po dito si P1, P2, and P4 po. At kapag na-complete na po natin yung process po natin, yun po yung maganda. Kasi mag-SAGF na lang po. Parang dire-diretso lang po natin siya. Dito po si P2. P2 pa rin po. Kasi po magiging 12 15. Magiging 0. At yung lowest po natin yan is si P4. At kukusyon na po natin siya lahat is magiging 21 po ito. And sunod po natin is si P1. And kukusyon na po natin siya lahat is magiging 30 po ito. 30. Sunod po natin gagawin is si yung ano na po niya, CPU, yung build po. And yung anin po natin ito is yung total nitong burst time is si 30. And yung end nitong si arrival time nung table nitong si ginawa natin process na divide nyo to sa 30. And times po sa 100 is equal po is 100%. Yan po siya. And yung sunod po natin hanapin is si end time, turnaround time, and si waiting time. At magsimula na tayo dito kay P1. At yung end time naman po ni P1 is si 30 po. At yung end time po ni P4 is 21. Ito po siya. At yung end time po ni P2 is 15. End time naman po ni P0 is 11. End time naman po ni P3 is 7. At makukuha naman po natin si turnaround time. Ganito po. Si end time is minus dun sa arrival time. 11 minus 3 is equal to 8. 30 minus 5 is 25. 15 minus 8 is equal to 7. 7 minus 0 is equal to 7. 21 minus 12 is equal to 9. At yung sunod na po natin is waiting time. Makukuha po natin si waiting time is dito po. Turnaround time is minus dun po sa first time na 8 minus 4 is equal to 4. 25 minus 9 is equal to 16. 7 minus 4 is equal to 3. 7 minus 7 is equal to 0. 9 minus 6 is equal to 3. At yung sunod na po natin hanapin is yung average ng turnaround time po natin. Total po ng turnaround time natin is 56. Divide po natin siya doon kung ilang po yung process natin is 5 is equal to 11.20. Average waiting time naman po natin ang sunod natin hanapin is equal ilang po yung total po ng average time po natin. 26. Kasi i-divide po ulit natin siya doon kung ilang po yung process natin na 5. 26 divided by 5 is equal to 5.20. Yan po. Ganito po yung process natin para po makuha po natin si SRTF po natin. Yan po, and thank you.
The round-robin scheduling is specifically designed for time-sharing systems for one CPU that has a lot of, it shares a lot of the system. It has a lot actually. No, it's the same to first come first serve scheduling, but preemption is added to switch between the processes, and also a small unit of time called a time quantum or time slice is defined generally from 10 to 100 milliseconds. And in this round robin scheduling is the ready queue is treated as a circular queue because the CPU scheduler goes around the ready queue, allocating the CPU to each process for a time interval of up to 1 time quantum. Now, in round robin scheduling, we keep the ready queue as a FIFO queue of processes. This is also where the new processes are added to the tail of the ready queue. Now, the CPU scheduler picks the first process from the ready queue, and it sets a timer to interrupt after 1 time quantum and dispatches the process. Now, one of two things will then happen. The process may have, should the process may have a CPU burst of less than 1 time quantum, then the process itself will release the CPU voluntarily, automatically. Then the CPU scheduler will then proceed to the next process in the ready queue. Now, should the CPU burst of the currently running process longer than 1 time quantum, then the timer will go off and will cause an interrupt to the operating system. And then a context switch will be executed, and then the process will be put at the trail of the ready queue. Then the CPU scheduler will then select the next process in the ready queue. So it's like there's tail and there's a head, then there's a line. Priority scheduling. Priority scheduling is associated with each process, and the CPU is allocated to the process with the highest priority. In priority scheduling, the equal priority processes are scheduled in first come first serve order. An SJF, or also known as shortest job first algorithm, is simply a priority algorithm where the priorities in the inverse of the predicted are given next CPU burst. The larger the CPU burst, the lower the priority, and of course it's vice versa. Priority scheduling can be either preemptive or non-preemptive. A preemptive priority scheduling algorithm will preempt the CPU if the priority of the newly arrived process is higher than the priority of currently running process. And while the non-preemptive priority scheduling algorithm will just simply put the new process at the head of the queue, the ready queue. Now for an example, given there's a process ID P1 with a burst time of 10 and priority of 3, process ID P2 with a burst time of 1 and priority of 1, process ID P3 burst time of 2, priority 4, process ID P4 burst time 1 and priority 5, and last P5 with a burst time of 5 and priority of 2. Now, consider the following set of processes assumed to have arrived at time 0 in the order P1, 2, 3, 4, 5, with the length of the CPU burst given in milliseconds. Using the priority scheduling, we will schedule these processes according to the following Gantt chart. We will arrange it priority. The first is the P2, since its priority is number 1, and then P5 because its priority is number 2, and then P1 because its priority is number 3, P3 because the priority is 4, and P4 because it's 5. Hence, the waiting time for P1 is 6 milliseconds, waiting time for P2 is 0, waiting time for P3 is 16, the waiting time for P4 is 18 milliseconds, and the last is the P5, which is 1 millisecond. Now, the only problem with priority scheduling is that with priority scheduling algorithms, it has an indefinite blocking, or what you'd like to call starvation. And it also has a process that is ready to run but always waiting for the CPU that will be considered as blocked. It has a priority also that can leave some low priority process waiting indefinitely, so it can be a lot of time. And of course, and at last, if there is a heavily loaded computer system, especially in a steady stream of higher priority process can prevent a low priority process from ever getting to the CPU. That means if there's a big system and there's just a lot of higher priority processes, the low priority sometimes does not reach the CPU. Therefore, it's not going to be processed. Though there's a solution to the problem of indefinite blockage of low priority aging, which is the low processes, which is called aging. Aging is a technique of gradually increasing the priority of processes that wait in the system for a very long time. Now, in multi-level feedback queue scheduling, in here it allows a process to move between the queues. The main idea here is to separate processes according to the characteristics of their CPU bursts. Now, if a process uses too much CPU time, then it will be moved to a lower priority queue. This kind of scheme leaves input and output bound and interactive processes in the higher priority queues. But also, in addition, a process that waits too long in a lower priority queue may be moved to a higher priority queue if it takes very long time.